Okay, so as far as I remember, we are doing a lab. So we on the day number one, we went through the theoretical topics, and the same theoretical topics were discussed over on lab on the day number two. Okay, and this is day number three. If you count it as per days, so today is a day number three for OSPF. So also I remember there was one small topic which I was not able to discuss in the day number two. Okay, so that was the one small portion which due to the time constraint I had told I will discuss in the next class. So that is okay. Let me check the workbook once. So that was regards to the multicast IP address. Yeah, the last task was to verify the multicast address. So we had done the initial configuration. We have configured single area OSPF. We have seen the DR BDR elections. We have checked out router ID election, the way to configure router ID. We also have manipulated the hello timer. We have seen how the neighborship get interrupted as soon as you change the hello timers between the two router in the case of OSPF. We also have checked area ID, authentication, area type, MTU mismatch. So basically these are the topic which deals with neighborship formation. Okay, fine. So apart from these lab, there was one small lab left over in the previous class. That was the DR and the DR others. Okay, so basically they make use of different multicast address. Let me tell you. Let's say I have a switch. I have couple of routers with me where I'm running OSPF. So as we know, over here there would be one DR elected, and DR has a formula that is called priority plus the router ID. The highest one will be preferred as DR. So let's say the R4 takes the election, it wins the election, and DR is this. Now the second lowest will be declared as BDR, backup designated router, and the rest of two will be placed under DR others. Okay. Now let's say there was one network which goes down. All of a sudden it goes down. Now in a multi-access area, what is the drawback of multi-access area is, let's say now those updates are sent. Okay, now the switch will do a flood. It's gonna flood to every other router, and the routers are going to synchronize. They are going to send back the updated packet. They are going to send acknowledgement, and there are so many broadcast happening. So what we are going to do in the case of OSPF is we are going to select DR and BDR. So in this case, whoever is sending the multicast packet in informing about the network that's down. So basically this multicast address is listening on this IP. Okay, 224.0.06. Now who is capable of listening to this address? It's your DR and BDR. So your DR and BDR have a capacity to listen on this multicast address additionally. Okay, so you know by default they are listening at 2240.0.5. Okay, both are listening at 2240.0.5, but additionally this is another multicast address that DR and BDR is capable of listening. Okay, so now this multicast update is being sent to the switch is going to broadcast. Unfortunately the other router which is only listening at dot 5, they are going to drop this packet. Okay, so this particular packet will be sent towards BDR and it will be sent towards DR. Now BDR knows that there is already a elected DR, so I don't have to do anything with respect to this packet. So it's going to drop that. Okay, and the packet that is received at DR end, it's going to update its database, and it's going to send those updated packet to rest all of them on 224.0.0.5. Now this is being enabled, or these are multicast address which is enabled on DR others all as well as BDR. So that's how the BDR also get updated at 224.0.0.5, and along with BDR the other router like DR other, they get updated. Okay, so let's prove this over on lab. So whatever you deal across with the theoretical topic, I always suggest go and create a smaller topology and just prove yourself. Okay, fine. So from the previous lab, I'll just consider these 5 routers. Okay, so let's see which router has taken up the DR election. So from the numbers, I believe it should be the Mumbai router 7, due to the fact it has a highest routing ID of 7.7.7. But yes, depending upon my configuration, it should have taken some anyone. Okay, so let's give it a try. Let's see. So I say show IP OSPF interface E0/0. No, so this is not taken as DR other. So what I'm going to do is I'm going to kill the process and go with the re-election. Clear IP OSPF process. Yes. Okay. So I need to do this on all of them. Okay, so looks like they are getting re-elected. So as of now, it's under state waiting. Okay, now it has taken the DR election. So now this router 7.7.7 has taken the DR election. Fine, so that's great. What about the BDR? So I hope this is gonna be the BDR. Yeah, so this is a BDR now. 7.7.7.7 is your DR and 4.4.4 is your BDR. Rest are 1.1 and 2.2. So obviously they are going to be DR others only. So we can just give it a try. Okay, show IP OSPF neighbors. So if you see now, 2.2.2 is DR others in a two-way state. Okay, just reserving 2.2.2. Okay, as of now there is no update going between this DR. Okay, so basically why does they achieve the two-way state? Okay, so basically you will see this two-way state between two DR others. Okay, these two routers, let's say this is R1 and this is R2. Now if they are elected as DR other, they don't need to be locally talking to each other, because R1 is connected to DR and DR is also connected to R1. So you don't need this communication. So they can remain in two-way just to avoid the unwanted link state advertisement. Okay, so we are going to keep those two DR others, instead of full adjacency we are going to keep them at two-way just to avoid the unwanted LSA. So they are going to have full agency with the BDR and DR. Fine. Okay. Now let's say one of the DR router, let's say this router. Now this is a DR others. Okay. This is 3, right? So this is 4. Now this is BDR, and where is my DR? So this is my DR. Okay. So what I'm going to do is, let's say I just shut down this loopback 1.1.1.1. If I shut down, now R1 is going to take that information on a multi-axis. So that's going to be broadcasted. Okay. But due to the fact that we know that they are going to be updated on this multicast address 0.6, so the others are just gonna get dropped, or they are going to discard it. Okay, because they are not listening at 0.6, they are listening on 0.5, whereas your BDR and DR, they are listening on two multicast address. One is 224 0.0.5 as well as 2224 0.0.6. Okay. So what I am going to do, I am going to run my Wireshark here to make sure that I can see the packet incoming over on .6. Okay. Okay. So as of now, you see all the packets are on .5, which is a default behavior. When is .6 coming into picture? When there is a network down and the update packet will be sent to DR first, right? So that is happening on .6. So let's check it out. Okay. So I'll go to the first router. Let's say I bring one of the loop back down. Okay. I just put this as shut. So you will see your first router immediately sent the update on which multicast address? On 0.6. Okay. Now who is listening at 0.6? It's your DR and BDR. Rest are gonna discard this packet. Okay. How do we prove that this IP that is .6 is listening by DR and BDR and the others are actually not? Okay. So what I can do is, let's say I make use of show IP interface Ethernet 0/0. So if I do this command, so you will see the multicast address that's enabled on 0/0 is .5. Okay. So this is some multicast address that deal with DNS. So it's not a OSPF. So don't be confused. There can be multiple multicast protocols, or there can be multiple multicast services. So it don't have to be that this interface only run only work for OSPF. Might be this interface is responding for DNS multicast packet also. So just discard this one as of now. Okay, we are not going on DNS part, we are studying the OSPF part. So from DR others, it's only listening to .5 OSPF multicast address. Now let's quickly go to the 7th router, that is Mumbai router 7, and if I see show IP OSPF interface Ethernet 0/0, okay, I think I just added up this word. Okay, so this is sufficient. Show IP interface Ethernet 0/0. So if you see now, your DR is listening on an additional multicast address, that is 224 0.0.6. You can see the same thing on the BDR as well, that is Mumbai router 4, show IP interface E0/0, right? So this is your BDR, this is your DR. Okay, and what about your DR others? They are listening only at .5. See, they have only .5. Okay, so that proves that whenever there is a network fluctuation, there is any addition, modification, those routers are gonna send those updated LS packet, okay, over on this multicast address, and now this multicast address is enabled only on DR and BDR. The rest are going to discard it. Okay, fine. So these are the two multicast address, and you know what is what now. Fine. So let's move on now. Okay, we have a lot to cover. Okay, advanced OSPF, where I would start with network type first. Okay, so there are like 5 network types or 6 network type, but the most used ones are broadcast, point to point, and there is one more which is called as loopback. Okay, the rest of the things like point to multi-point, non-broadcast, and the broadcast, they are used in the outdated worlds, or they were used in the obsolete technologies like frame relays or ATMs. Okay, so basically we don't use this protocol as of now, so that's why I will not focus much on the other 3, but yes, I'll focus on the one which we are using nowadays. Okay, the first one, the first network type in the case of OSPF is called as broadcast, and this is by default. As soon as you start OSPF, broadcast network point or the broadcast network type is gonna get uh, taken up. Okay, so yes, we can change the network type from broadcast to point or from broadcast to any other network type. You can also make it to point to multi-point or non-broadcast. You can just do it. Okay, but by default they are gonna be broadcast in nature. Now what is the difference between broadcast and a point to point? So as you know, broadcast is when you have the multi-access scenario. Let's say this is a network design R1, R2, R3 and R4. Now what kind of design are they? They are in a broadcast network type. Okay, the reason you have a switch in between which is broadcasting the packets. So in the case of broadcast in nature, there will be DR and BDR picked up. This DR and BDR is meant to be selected in the case of broadcast or multicast scenarios, because otherwise there will be a lot of broadcast happening if you don't take care of the DR and BDR. So what happens is, in a multicast or in a broadcast network type, there will be one router which becomes DR, the other one becomes BDR. Now all the communication happens over on DR. Okay, so the two DR others don't even have to form full agency. Let's say this is DR other and this is DR other. They don't have to be forming the complete agency. They just need to make sure that they are having full agency with the DR only. Okay, and the DR will send the updated packet every time to the other routers. That's in the case of broadcast network type. What is the multicast IP? So by default, they are going to take 224.0.0.5, and any update or any reply, it will be taken up on this this multicast address. Okay. In the case of broadcast, as you know, there are like more than 2 routers required. Like in this case, there are 4 routers that we used. Okay, so as like when I have a switch, I can connect multiple router. It could be more than 2, it could be more than 4, 5, or it could be anything. So depending upon that, the routers are more than 2 in the case of broadcast network type. And regarding the timers, it's by default 10 seconds for your hello, and for your hold it's gonna be 40 seconds. Now regarding to point, when do you save point to point? So when you have 2 routers connected oppositely. Okay, so let's say this is R1 and this is R2. They are connected on a opposite direction. Okay, they don't have any intermediate switch or something. They just are connected point to point. Okay, So in this scenario, let's say I have OSPF running up. I don't need DR and BDR. Okay. First of all, I don't need DR and BDR happening here because there are only two routers. Okay. So all the other networks which are behind this main routers, they are just getting advertised. They don't need DR and BDR in the case of point to point. That's why I say there is no election of DR and BDR. Okay. So by default, in the case of serial and tunnel interfaces, you will see point to point coming up. Okay. Serial and tunnel interface, they deal with point to point connection. Serial in the case of ISP connections, and tunnel in the case of IPsec connection. So basically they will be point to point connection only. Okay. Whereas in the broadcast, this is more in the case of LAN segment, multi access network. Okay. So the two major things over broadcast and point to point is you have election of DR and BDR, whereas there is no election of DR and BDR in the case of point to point. Multicast ID by default is 224.0.0.5. Okay. So in the case of point to point, it's strictly two routers. When you have two routers, they are called as point to point. If you want to have one more router, you just cannot say them as a point to point. You need to have a switch, and then you might have to connect this way. Now they form broadcast network. Okay. Timers 10 and 40 second. Now one quick question. Let's say I have a router here and I have another router over here. I have point to point and I have broadcast over here. So what do you think? The neighborship will form or neighborship will drop? So what do you think? On one side, I have a broadcast configured. Let's say this is E0/0. The network type of this interface is broadcast. I have this network, this interface where I have configured point to point. So what do you think? So let me just see the chat window. No. Why? Why do you think no? Media type, I don't think so. The media type wasn't a prerequisite for two neighbors in the case of OSPF. What are the prerequisite? It's your hello and dead interval, authentication, area type. Now don't get that confused area type with media type. Area type is stub, non-so stub. Okay. You had area ID and you had subnet mask. So where do you think there is something which is carrying the information of broadcast and point to point in the case of two neighbors to form or to form neighborship? Okay. Yes. So timer should match, and and if you see over here, the timers are same for broadcast and point to point. The timers are same. Okay. So this is a this is your technical interview question where interview ask all these kind of questions. So be prepared for all the silly type of question, because you never know from which point are they going to pick up. Okay, fine. So these are the two things, very important things, and main thing over here is election of DR and BDR, and over in point to point there is no election of DR and BDR. With regards to timer, luckily they are same, so we don't have to worry. Now when we talk about point to multi-point, okay, which is used in frame relays, so what happens is the timers get changed up. Okay, the timers now becomes 30 second and 120 second. The hello becomes 30, and automatically the hold timer or the dead timer get shifted up to 120 second. The multicast address are the same. they are not going to have any DR and BDR election because they are uh, as good as point to point only. Okay, they're point to point connection. So basically there will be no DR and BDR happening. The timers are changed. Okay, and the other thing with respect to point to multi point is there is automatic neighbor discovery. Okay, so basically this and this are gonna discover themselves in the case of OSPF. But let me tell you the next one, that is, let's say, so this was point to multi-point broadcast. Now if you talk about the next one, that is point to multi-point non-broadcast, in those scenarios there will be no automatic discovery happening. Okay, we have to manually define the neighbors. Okay, and what else in the case of these point to multi-point? You will see there is only one subnet. Okay, the both the routers, they have one single subnet. So let's say I have 192.168.123.1 configured here. I have 192.168.123.2. Similar way, I have 192.168.123.3. Okay, so they are all in one single network. So very similar to your multi-access. If you just remember the broadcast network type, which is example for multi-access. So they all were part of one single network, 192.168.1.0/24. Okay, but they were called as broadcast network. As of now, even though they are falling under one single subnet, we don't call them as multi-access. We would call it as point to multi-point broadcast. Okay, so there is no election of DR and BDR due to the fact point to point. Okay, so there is no election of DR and BDR. Yes, this is something you need to know. There can be more than two routers, whereas in the case of point to point there will be only two routers, whereas in the case of point to multi point there can be more than two routers. So basically three routers in here. Automatically the neighbors will be discovered. There is no DR BDR, only a single IP subnet is used. So you see the whole subnet is just a single subnet. All three fall under single subnet. Okay, what about point to point non-broadcast? They don't have DR BDR. They are gonna send unicast packets. There can be more than two routers. Hello timers are 3 and 120. There is no automatic discovery. Okay, in this scenario there was automatic discovery, but over here there is no automatic discovery. And yes, as you know, there is no DR and BDR because they still see the network as point to point. Okay, and they are going to be a single subnet only, something very similar to this single subnet, three routers. Okay, and no automatic, we need to manually define them. In the case of non-broadcast, which is again very similar to the two which we discussed just now, that is point to multi-point. So in the case of non-broadcast, you will see the only change here is they have DR and BDR election, which is now point number one. If you go back to point number one, in the case of broadcast, they elect DR and BDR. Okay, and rest from second, third, and fourth, there was no election of DR and BDR. But again, when you start with non-broadcast, there is election of DR and BDR. The timers are 3 and 120 seconds. So which is nothing but starting from the third point. So from this point, they were all 30 and 120, whereas the first 2 points, the first two types covered 10 and 40 seconds. Okay, starting from the third network type, they are following 30 and 120 pattern. Non-broadcast network type assumes you are running a multi-access. Multi-access in the sense there is a switch in between the three routers. Some key points about non-broadcast are multi-access will select DR and BDR. Non-broadcast means that OSPF expects us to configure neighbor ourselves. So we are gonna manually configure. In the case of non-broadcast, I am going to manually configure. Whereas in the case of broadcast, I was just enabling the routing process. They were following the SPF algorithm, shortest path first, and then we could see the neighborship happening, all those things. But in this case, I have to manually define the neighbors. And the last important thing here is the loopback. So by default, you open up any loopback interface, the loopback network type is gonna get selected. By default, /32 is picked up in case of loopback. Okay, this is one interesting question, and yes, from interview point also that's important. I'll just show you today while doing the practical. Let's say we have interface loopback 1 and I'm advertising loopback 1 under my router OSPF. Okay, so let's say I have advertised loopback 1, but when I check show IP route, okay, so let's say interface loopback 1 is on /24. Also in router OSPF, while advertising loopback, I am advertising /24 equivalent wildcard mask, because you know under OSPF they consider wildcard mask. So I'm going to advertise equivalent to /24. But when I go and check my show IP route, you will see they are taking up /32 only. Okay, even though you have advertised /24, it's taking /32. Now interviewer is going to ask, why is it happening, why is it happening, and how could you resolve this issue? So the answer for the first one is, in the case of OSPF take loopback as host. Okay, what are host? Basically hosts are on single IP, which is nothing but 32 IP, right? So by default loopback, even if you configure /8 or /16 or /24, OSPF will take loopback as host and they are going to put just /32. Okay, so this is a answer for the first question. Now the second question was, how do you change this? Let's say I want to change the behavior. I don't want it to advertise /32. Let's say I want /24 for my reason. Okay, now what I can do is I can change from loopback network type to point network type. So doing this change will bring out of that /32 to /24 or whatever /8 or /16. Okay, I'll show this while doing lab, but from theoretical point of view, just keep this and keep this with you. Okay, fine, let's go to the next topic, that's regards to LSA. Now LSA is very important topic. Okay, so if you remember from the previous class, we discussed LSA1, LSA2. Okay, so we see this LSA1 and LSA2 in single area OSPF. Okay, and this LSA2 is seen only in DR BDR environment. If there is no DR BDR, or in very short term, if there is no multi-access environment, then you will not see LSA2 generating. Okay, so this LSA2 is generated by DR router. Now let's go back to whatever I'm just telling. So what I'm going to do is I'm going to show you two topologies. So let's say I have one topology where I have area 0, and now this is an example for multi-access. On the other side, I have area 0, but it's for point to point. Okay, so multi-access, which is nothing but broadcast, the first network type, and the second network type was point to point. So in the case of area 1, let's say I have a switch connects to multiple routers, whereas in point to point it's strictly between two routers. Okay, so behind the routers you can have multiple networks. So OSPF is between the two routers in case of point to point. Now over here, when you have enabled all the OSPF process and you are aware of the tables like neighbor table, database table, routing table, if you go and check the database table, you would see LSA1 and LSA2. Okay, But when you go to point, the normal configuration, not anything complex, and if you open up the database table, you will only see LSA1. There will be no LSA2. The reason is LSA2 is been generated by the DR routers. So DR router election happens only in broadcast. So let's say this is a DR router. So this router is gonna generate LSA2. Whereas in the case of point to point, there is no DR and BDR election. Okay, so you will not see any LSA for LSA2. Okay, so that's why you should remember all these minor points. Okay, so in the case of broadcast, there is election, but in the case of point to point, there is no election. So though no election, no LSA2. There is there is DR, then DR is going to send LSA2. Now we need to know what is these what are these things doing in reality. Okay, so let's say I have two router inside area 0. As I told you, when there are only two routers, they are forming the initial neighborship. Once the neighborship and the adjacency are formed, they are gonna send the LSA packets. So these LSA packets are your update packet. It could be reply packet. Okay, it could be acknowledge packet. So based on those content of these LSA packet, we can classify them. So let's say they just form the neighborship and now they are two neighbors. Okay, so the first LSA type, or if I write it as LSA1, now they are going to tell me about their neighborship relation. Okay, so if you see from this diagram, the R1 is gonna say I am with neighborship with 2.2.2.2. Similar way, R1 is going to say I am with neighborship with R1 on this IP address. So you will expect something like two neighbors details on your LSA1 column. Now what would be the content of LSA2? Okay, LSA2, which is generated by DR, designated router, in the case of multi-access. So let's say this is DR. Now DR is going to say, or DR is going to broadcast its network address. So let's say this network is 192.168.23.1. Now the work of DR is to say that I am advertising at this network 23.1. So in the case of LSA2, you will see 192.168.23.1 advertised by DR and all other values. There will be no other information. Whatever DR wants to advertise, that information will be put up in LSA2, and we call it as network LSA. Whatever network the DR is been advertising. Okay. First one is called router LSA or type 1, which is originated within the area, flooded within the area, tells the area about all the links participating in the OSPF process within that area. So basically the neighborship relation. So there could be many other routers in the same area. So you will see multiple links or the neighbors in the LSA1. LSA2 originated by DR. If there is no DR, there is no type 2 LSA. Now let me talk about the LSA3. Okay. So this LSA are generated when you have multi-area configured, multi-area OSPF, which we have not done so far. We just did one single area OSPF, right? Now what is multi-area? Let's say I have area 0 where I have bunch of routers, and I have another area. So let's say this is called as area 40, and there are bunch of routers. Okay, and let's say there is one more router which is acting as the ABR. ABR are nothing but area border route. Okay, so what is the work of this ABR? The ABR is gonna send or inform all the networks to area 0, and similar way, whatever the networks or the links are being read in the case of area 0 OSPF, that's going to be on this side. So basically they are gonna keep different, or they are gonna keep the track of every links. So basically this ABR is gonna generate something called as network summary LSA. Now what is network summary LSA? It will be generated by ABRs. In this case, this is a ABR, area border router. So this ABR is gonna tell that we have so and so many links inside area 40. Okay, so this ABR is gonna tell about all the networks, or the different type of network to area 0, and similar way all the network type, or whatever network or the prefix length you have in area 0 will be advertised in the area 40. So basically this router will know how to reach this route, this person. Okay, so there will be end to end reachability, end to end ping reachability. Who is taking care of that? That's your ABR. So what is ABR gonna do? ABR is summarizing the network, and we call this kind of LSA as LSA3, or we can also call it as network summary. Why do I make use of the word summary? Because whatever I have been advertised, or whatever I have inside area 40 is getting summarized inside area 0. Similar way, whatever you have configured under area 0 are now getting advertised in the case inside area 40. Okay, so your ABR is summarizing. It's trying to have a consistent routing, so that both the areas can communicate to each other. So let's say in this scenario, I have area 1, I have area 0, area 1 and area 2. Now these are two ABRs. I have one ABR here, I have the second ABR over here. So let's say I have a network 4.4.4.4 and I have a network 2.2.2.2. Okay, now if I want to ping from R1 to R4, the traffic will go on this path. Okay, so all the networks, or all the networks will be advertised over here, also over here, and similar way whatever networks you have inside area 2, that will be advertised in area 0 and area 1. So basically they will keep their records, they will know each and every path. So this router 1 knows how to reach 2.2.2, the destination 2.2.2. Who is contributing to this kind of communication? It's your ABR routers. Okay, so your ABR routers are making sure that they have communication. So this is in the case of OSPF. I'm not talking about any other protocol, I'm talking about OSPF. Let it be area 0 or area 1 or area whatever, but after all they are part of OSPF only. Okay, so to have end to end reachability within OSPF, this type 3 LSA is helping us. Now let's come out of the OSPF scenario. Let's say I have EIGRP now. Now there are two different things here. So this would be one autonomous, this would be another autonomous system. Okay, so when I have this kind of scenario, when this is completely OSPF, okay, and this is external routing protocol. Now let's say I have multiple networks here. Let's say I have 200 200 200.0, I have 113 113 113.0. okay, so let's say these networks should be also advertised inside OSPF, so that my user who is sitting over here can reach to this network. Okay, so let's say there is some file machine here, or a file server here, which is on this network, and I have a user here. Now let's say he is downloading some file, or he is uploading some file. So how would his packet travel? So it will hit the first router, it will go second router, go to the R2 ABR, it will go to R1, and from R1 it will go within the EIGRP, and then it will reach to the file server. Okay, so there should be some reachability from OSPF and towards EIGRP. Now, who is going to take care of this kind of communication? So you know there is LSA1, which is between the two routers. You also know there is LSA2, which is generated by DR. Okay. Now let's say there is no it's not a multi-access network. It's just a point to point. So there is no LSA2. So we can say LSA2 is just an optional in the case. Okay. Now what is LSA3? So yes, we need LSA3 because that's how the inter area are going to get communicated. Now which is the LSA that's gonna take care of these external routes? So that's called as LSA 5, link state advertisement 5. Okay. So whole this network, let's say the 200 and 113 network, if they need to be advertised here inside the OSPF premises, so let's say I will have one router here. Okay. Now this router will be called as ASBR. Okay, autonomous system border router. Now this router is connecting two different routing protocol. On one side you have OSPF, on the other side you have EIGRP. Now this routing protocol is going to emit the LSA 5. Okay, and what are these what are these LSA 5? They are nothing but they are the external routers, external routing information. Okay, so basically this network will be advertised within OSPF with the help of LSA 5. Okay, so that's okay, that we are good with LSA 5, that this the LSA 5s are nothing but external routing protocol. Now from let's say area 0, let's say I have some user here. Now this user is connected to R1, R1 is directly connected to ASBR, and this ASBR is now directly connected to EIGRP. So things are all pretty simple. Now let's say the user who is connected to this. Okay. Now how would this user know that his traffic should go in this direction and not in other direction? Let's say there were some other routers or as well. Okay. So how is this user gonna know that his traffic must be sent to this ASBR and not to any other ASBR? That's your LSA 4 comes into picture. Now LSA 4 act as a gateway. Okay. So what is LSA 4? Basically it will be the IP, or it is the IP address of this ASBR. So let's say the ASBR is acting as LSA 4. Now in very simple word, let's say I have to send a file. Okay, so I'm talking from this person point of view. Where does this person send the traffic, or where this person has to push his traffic? So basically he will push it to this router. Now this router will know to reach to an external routing protocol, I must forward to this ASBR. The ASBR will now take care of the external routing. Okay, and that's how this is going to work. So you have LSA 1, LSA 2, LSA 3. LSA 4 is nothing but the gateway. Okay, so your only concern is to reach to the LSA or to reach the ASBR. Once you reach to the ASBR, ASBR know how and on which direction to be taken forwarded. Okay, so this is one simple example of EIGRP. There could be one more external routing protocol, RIP, or you could have BGP. Okay, now the file transfer is happening between OSPF and the EIGRP, right? So it is your ASBR who knows how to proceed further, or what to be done next. So your concern is from let's say you are good with LSA 3. Now we are talking about external routing. So the concern is to reach to that external routing EIGRP. What is the gateway? Which ASBR is gonna take this, or take the whole functionality to do this delivery? The ASBR could be anywhere. There could be ASBR here, which is connecting with the EIGRP, where there are other networks. Let's say there were some other EIGRP networks, and you had another ASBR. Okay, so each ASBR will have LSA4. So this is going to have LSA4, this is going to have LSA4, and this is going to have LSA4. Now to reach so and so external routing or external route, which is nothing but LSA5, how do you send the, or whom do you send the packet, right? So that's your LSA4. So let's see the definition, or let's see from the definition point of view. Okay, ASBR summary, as I told you, that's generated by ASBR, originated by ASBR, tells all other areas about the ASBR. Okay, tell other areas to get to this external routing, go through me. It is basically acting as a gateway to reach LSA5. LSA5 is pretty simple. It's nothing but it's the external routings. Okay, originated by ASBR, flooded throughout the OSPF. Okay, consist of network prefix, subnet mask. Examples: RIP and EIGRP. Like for example, if you see here, these are external routing protocol. Okay, on other side you have OSPF. Now if you want the network, these networks to be advertised till area 2, now your ASBR will take care of two new LSA. One is LSA4, the other one is LSA5. LSA5 pretty simple, that's nothing but this network which is now converted into something which OSPF can recognize, right? So let's say I have BGP network 113.113.1.0 221 so and so. Now how do you think this network, the BGP network, the OSPF could have recognized? So basically you have to convert this into some OSPF recognized OSPF recognized components, right? So that's your LSA5, which is nothing but external routing. And as I told you, there can be multiple ASBR. So your packet can get just expired if they travel on different direction. So basically the packet, if they travel to the right ASBR, then the packet will be replied back, and that's how your communication is gonna be end to end. So basically LSA4 is again emitted by ASBR. Okay, and the work of LSA4 is to tell other areas. I'm not talking about the users who are connected on this area, because they know that that we are connected via so and so with external routing protocol. Okay, interesting factor is if you ever open the database table here on area 1, you will not see LSA4. There is no LSA4. The reason is very simple. Why is your user need LSA4? Why do you need a gateway? Because they are directly connected, right? This act as a direct connection. So you will not see LSA4 in the case of this area. But from the area number 2, the users here, they might get lost. There might be their traffic go on the different direction. Okay, so basically to point those traffic towards the rightful ASBR, which is acting as a gateway, and then the ASBR is gonna send the traffic to BGP, then get back the traffic and then push it back to area 2. Now that's your LSA4. LSA4 is acting as a gateway. Okay, so we will see this in the case of lab. Okay, now type 7. Okay, now what is non-so stubby area? Okay, now there is one more thing over here. Let's say let's say I have external routing over here. I have LSA4 and LSA5 generated. Now let's say I have those routes also advertised on area 0. But For some reason, I don't want these external routes to be advertised inside area 2. Okay, just to avoid unnecessary overhead on the routers. Okay, I don't have any requirement to ping the external routes, so I don't need their LSA 5. Okay, I don't need LSA 5. So when such scenario comes, what I can do is I can just put them under stub condition. The moment I put under stub, stub is going to take out the external routing features. So it's going to disable the external routing feature. So as soon as you suppress those external routing features, so basically you're just making it as no LSA 5. You will not see any LSA 5 in this region, in area 2. Okay, no LSA 5, and this condition is called as stub. What is stub? When you're suppressing the external routing. So how is it going to work? Let's say I still want to reach, but I don't want the individual networks. Okay, see, my condition is I don't want individual network. Let's say over here I have 113, I have 224, I have 10.10 dot something. Now all this by default would have been in my routing table. I could see 113, 224, 10.10 on my routing table. Now I don't need that. But at the same time, let's say I want to reach them. Okay, I don't want these individual external routing network in my routing table, but still I want to ping them. Now what I do is when I create stub, it's gonna create a default summary route. Okay, and the summary route will look something like this, and it will point out to the gateway. So what happens is these individual networks are gonna taken down. So these individual network will be taken down. These will be replaced by a default summary gateway. So we will see this. Just give me some time. We will see this stub scenarios. Okay. So that's all about stub. Now let's say I have one more area here. Okay. Let's say I just made this area as stub. As soon as I bring up the stub feature, they are going to suppress the external routing capabilities. Okay, there is no way my external routes now can reach to area 100. Okay, so in this scenario, what I'm going to do is I'm going to make this as non so stubby area. So what happens is it's gonna convert those LSA 5 to a new LSA called as LSA 7, and then those LSA will be sent to the next area. Okay, so this is in the case when you still need the external routes to be pushed to the next area. Okay, now if you have stub here, stubs are going to suppress all the external routes. Okay, so you don't need that scenario. Okay, so to avoid such scenario, what I can do is I can convert them into non so stubby area. As soon as I do that, still my LSA 5 will be suppressed. Okay, there will be no LSA 5 in this region, but instead of LSA 5 there would be a new LSA generating, which is LSA 7. Okay, so this LSA 7 will take care of all the individual route and it will push it to the next area. Okay, so these are overview of LSA. The more we do practical, it will be clear. Okay, so as I have written here, there is no external type 5. Okay, OSPF area types: backbone area called as area 0. The standard area, as you know, anything from area 1 till this number forms standard area. What is stub area? Stub area is something where you don't see type 5 LSA or the external LSA. There will be no external routes. Okay, the routes learned from other protocol like BGP, EIGRP. just to reduce the size of database. So a default summary LSA with this prefix will be put up in the case of stub area, because they still want to reach to the external route, but they don't want the individual routes to be learned. Okay, so I can show that. Okay, let me complete this and then it would be easier for me. Okay, 1 second, I'll better show it. Okay, so let's go to this lab topology. So let me tell you what all things I have done first. Okay, so I have area 0, I have area 40, I'm taking this as EIGRP, and I'm taking this as what do you say, okay, so I'm using this Rome data center for, okay, for stub, let's say for stub. Okay, so what happens is this EIGRP routes will be flooded here and it will be taken to area 0. Now let's say, so what happens is, so those external route will still reach to Rome. Now I don't need those external routes, so I can make them as stub. As soon as I make them as stub, I can see my EIGRP networks get replaced by 0.0.0 and pointing towards the gateway. Okay, so the things what I've done is I have configured OSPF. I'm going to configure OSPF over here. Now they form multi-area OSPF. Okay, there is one more OSPF section here between them, and over here I have EIGRP, and on this router I'm gonna do redistribution. Okay, so I'm going to inject EIGRP routes inside OSPF. Similar way, the OSPF routes I'm going to inject inside EIGRP process. Okay, fine. So I have the initial configurations, that's like IP address on all of them. Let me quickly show on my first area, that is area 0. Let me show you the OSPF that I am running. Okay, so I'm running OSPF 100. I'm advertising my loopback address and my interface address. So you will see the same default configuration on Mumbai router 2, 3, 7 and 4, which is nothing but area 0. Okay, so you will see some similar kind of routing or similar kind of OSPF distribution. Okay. Okay. So in the case of 7 and 4, what I have done is I am advertising via interface. So I am advertising over interface. Now that's pretty simple. So I go to interface E00. I say IP OSPF process number 1 and area 0. Okay. Which was pending in the last class. Last class I showed you the centralized way or global way. So just to show you the other way of doing OSPF configuration, I'm making use of interface now. Okay, fine. In the case of area 40, what I do is area 40 is shared with R4, R5 and R6. Okay, so R5 and R6 are in a point-to-point OSPF connection. The rest are multi-access. This is multi-access. Okay, uh, from this point of view, they are multi-access, but from these two point of view, they are point-to-point. Okay, so we will see what is the difference between that. How is it different? Okay. Okay, so in the case of Mumbai 4, let me show you what is the configuration that I have done for OSPF. So I'm still making use of interface based OSPF configuration. If you see my interface, that is 0/0. Now 0/0 is the interface which is on the area 0 side. Okay, so you will see area 0. Now the second interface will be pointing to area 40. Okay, so there you go. So this router Mumbai R4 is nothing but it's a ABR router, area border router. So that's why you see the configuration accordingly. You will see one configuration pointing to area 0, other configuration pointing to area 40. So we can see the database now. So let's see what is the database on the first router. So if I go show IP OSPF database, so let's see what do I have. So you will see the additional LSA, which we had not seen in the previous class. We had seen only the first two LSAs, right? LSA 1, which is router LSA, and then we had seen the LSA 2, which is emitted by DR. Okay, so in this case 7.7.7 is acting as your DR. So what is the network that DR is advertising? It's your 23.15. so that is what LSA 2 is gonna say, that I am the DR, I am the advertising router DR in the case of area 0, and this is my network. Okay, LSA 2. So this was the two LSA we checked in the previous class. But as soon as you bring up two different areas, you are gonna see the LSA 3. Now who is going to emit this LSA or this networks? That's your ABR router. So this ABR router, area border router, is gonna send this LSA 3, which is called as network summary route. Summary is nothing but the summary of this route advertised inside area 0, summary of area 0 getting advertised on area 40, something like vice versa. Okay, so what is LSA 3 gonna say? These are the networks that is inside area 40. Okay, you have 5.5.5, which is nothing but loopback address of this. Similar way you will see the loopback address of router 6. This is the network 10.100, which is the multi-access network, and also you have 17.16. now what is that network? That is this network, point to point network. Okay, so this particular database, if you go across and see on R5, which is on a different area, okay, so you will see the similar behavior. They are gonna keep record of all the links. So in this scenario, if you see, you have reachability with 2.2, you have 3.3, okay, you have network 23.3. so basically you have reachability till the end. We can give a try. Let's say I am on the first router and I want to ping this. Okay, if I go to the first router, if I give a ping, so they are reachable. Let's see on which path are they traveling. So they went first towards 23.14. now what is 23.14? now that's nothing but the ABR, okay, this interface. So the ping traffic first hit on this. Now this ABR know how to reach 5.5.5. now 5.5.5 is nothing but inside this router 100.2. okay, so they are having end to end reachability. The database are synchronized. It's your LSA1, LSA2 and LSA3, which is seen in the case of two different areas, and especially in the case of DR and BDR environment. Now from point to point connection, let's see what happens. Okay, so if I open up Mumbai 5, if I see show IP OSPF neighborship, so you see they are neighbored with 6.6.6, 4.4.4 and 6.6.6. okay, so let me see what is the OSPF running on E0/1. so on this, let's see what is the OSPF by default taking up. Okay, so by default they are taking a broadcast. Now let's say I want to change the behavior. I go to interface E0/1 and I say IP OSPF network. I just want to change that to point to point. Okay, by default it has taken broadcast, but I want to change it to point to point. Okay, so once I do that, it said that the neighborship is gonna down. OSPF network type mismatch received from network type mismatch, and then we see loading happening. Okay, so let's give it a try. Let's see what is show IP OSPF neighbors. So if you see now, they have formed the neighborship, but there is no BDR and DR election. Okay, I can cross check by shutting down E0/0, because yes, the neighborship can also form in this way also due to the multi access, right? So to avoid such kind of confusion and just to keep the relationship over on the point to point, what I am going to do is I am going to turn off one of the interface, that's E0/0. So let's shut it down. Okay, so it's gonna lose neighborship with other side, but at the same time it should have network OSPF network relationship on the point to point side. So what does it prove? It proves two things here. One, in case of point to point there will be no BDR and DR election. Point number two, even though you have point to point on one side and you by default have broadcast on other side, they are still gonna be a neighborship, OSPF neighborship. Two things that we checked here. Okay, fine. So this is what you see when there is no DR and BDR. They have formed full adjacency. Okay. On the other side, if we go towards other side, that is Mumbai router 6. One second. Okay. Mumbai router 6, and I'm going to change the network type. IP OSPF network type point to point. Okay, so the reason is they have the other interface up, but yes, I can take it down if they create confusion. So you can see there is only one OSPF neighborship. There is no election, and in the case of point to point and broadcast, they were still forming the neighborship. Okay, fine. So that's proved. So what else can I show you here? Okay, now regarding those network types like stub, LSS, all those things. Okay, so as of now you will see only the three LSS: LSA1, LSA2, LSA3. So yeah, one more thing that I would like to show you. In the case of point to point, you will see only LSA1 and LSA3. There will be no LSA2. The reason is, who is emitting these LSA2? It's your DR. If there is no DR in the case of point to point, so there will be no LSA2 as well. So you see only LSA1 and LSA3. Okay, there is no LSA2. But if you go back to one of the router which is in a broadcast network, IP OSPF database, you will see LSA2 here. Okay, so this LSA2 will be not seen in the case of point to point connection. Okay, now what I'm going to do is I'm going to bring external routing. Okay, so what do I need for external routing? So let me go to the Tokyo router, Tokyo R7 router. Okay, this router. So for on that router, I have taken up one interface, Ethernet 1/0, and I'll just make use of this network ID. Okay, 113.23.23.2. So inside R7, let's see the interface first. Okay, so as I told you, I have this interface, and what am I advertising inside EIGRP? So I'm advertising two different networks like 113 and 114. Okay, so I'm advertising these two networks. So who is my ASBR? My ASBR is this router, Mumbai 6. So let me go to Mumbai 6, because I need to advertise, or I need to pull those EIGRP route and inject inside OSPF. Okay, so as of now I only have interface IP, show run interface E10/0, which is facing towards EIGRP, or the towards the Tokyo router. Okay, okay, and I think I have put down one of the interface here, that was 0/0. Yeah, so I'll just bring it up. No shutdown. There's one more over here, which I will get it down so that I don't fall into any traps. Okay, so this interface was put into shut to show you the point to point scenario. Okay, so on Mumbai router 6, I need to configure routing process. So I have the routing process. What about EIGRP? Okay, so there is no EIGRP process. Now let me tell you how is this redistribution happens. So we have a dedicated class for this, but as of now just understand, redistribution is something also called as translator. So this router where we're going to configure redistribution must know both the process, that is OSPF as well as EIGRP. Okay, so within OSPF I'm going to inject EIGRP routes, and within OSPF within EIGRP I'm going to inject OSPF. So this is a router which will act as ASBR, autonomous border router, which is being shared with EIGRP on one side and OSPF on the other side. Okay, so the two configurations are important. So I go to router EIGRP, and what is the autonomous system? So that is 100. Okay, to form EIGRP neighborship, the mandatory thing is only the autonomous system. The other things like timers and all are not important. Okay, so this is my autonomous system. I'm going to advertise these networks. I'll just copy and paste it here. So I can see the EIGRP coming up. Okay, so the EIGRP has come up. So how do I check? Do show IP EIGRP summary. So I'm forming the EIGRP relationship between these two. Okay, so I'm forming some kind of EIGRP distribution. Do I see this 113 on this side? We can give a try. Okay, so I have not done any configuration. So let's see, do I see 113? So I don't see as of now 113. The reason is I have not redistributed. So until you do redistribution, you will never see the routes. Okay, now how do we do redistribution? Not very difficult commands. It's very simple. Let me tell you. So in the case of ASBR router, so in my case it is Mumbai 6 router. Okay, so first I go towards the OSPF process, so which is router process 1, and here I am gonna inject the EIGRP routes. So while injecting EIGRP route, I make sure this EIGRP routes, okay, this EIGRP routes take the standard of OSPF. So how is OSPF gonna learn? It's based on metric only the cost metric. Okay, so it's simple in case of this. So I'm going to say, what is the autonomous system? 100. What is the metric that OSPF follows? So what is the default metric? So by default OSPF is considering 10. How can I check that? I can check it on one of other routers. So let's say over here, if you see, OSPF is taking a cost value of 10 by default, because we are making use of Ethernet links. If I would have making use of fast Ethernet or Giga Ethernet, my cost would have been 1. But since I'm making use of Ethernet, my cost is 10. So keeping that into consideration, I'm going to say my default metric is 10. Okay, and I'm going to keep this for all the subnets that I'm gonna advertise. Okay, so with this command, I just injected the EIGRP routes within OSPF. That is like one way I did. Now I need to do the similar thing inside EIGRP process. So I go to router EIGRP, and as you know, the autonomous system is very sensitive here. So make use of the right number. Now you need to distribute OSPF route inside EIGRP in EIGRP way of understanding. How do EIGRP understand the metric, or how do EIGRP calculate metric? Based on 5 factor. One is bandwidth, delay, load, MTU, okay, so based and reliability. So based on these 5 factor, EIGRP calculates its path, right? So we need to follow that pattern. So I go over here, I say now I am redistributing the OSPF route. Which OSPF process? It's 1, I guess. Let me double check. Yeah, it's 1. Okay, so I'm going to redistribute 1. Now I need to define the metric style. So first is bandwidth. Now on which bandwidth should I take it as by default? So I can go back to one of the router and I can just quickly see here. Okay, so if I see if I say bandwidth, okay, so bandwidth is this by default. So I'm going to take this and place it here. Now those are already in kilobits. Okay, so I don't have to convert or do something. I just took this value and I have pasted here. What is the next factor that EIGRP make use of? It make use of delay. How do I get delay by default? Delay is also over here. So I can just get that and enter here. Okay. Now in the next case, it's reliability. So if you enter 255, that is you have 100% of reliability. So I'm going to keep the default value. What is the metric, or what is the loading factor? Okay, so again I'm going to keep the 100% or the default behavior. What is the default MTU? It is 1500. Fine, I have done the redistribution in 2 ways. Now let's see, are the routes getting spread out throughout, right? So I go back to my router 1. If I make use of show IP route EIGRP, so there are no routes still. Okay, what about OSPF? Okay, so there are OSPF routes. Okay, and the EIGRP routes are now learned over OSPF, okay, with the tag of E2. So if you go back to my day 1, I was talking about OSPF has a external tagging facilities, right? So this is called as external route facilities. Now what is 113 and 114? Those are nothing but those are the EIGRP routes, right? How can I check? So if I show you here, so these are the Tokyo routes. Okay, if I show here, Tokyo is this EIGRP. So this network, these routes are now on this router, your Mumbai router 1, okay, which is running on OSPF. So it is learned over OSPF, okay, and over on E2 tag, external routing. And these are the 2 network. So how can I double check? I can make use of show IP route. I can type this network, okay, so it says it's learned over here. And let's say if I go with the actual IP address, let's say this IP address, okay, so from this entry or this output, it's gonna show me that this is the distance, OSPF distance, this is the metric, this is the external tagging, forward metric, this is the last update. So who is advertising this? So basically, to reach this network, so let's give a trace route. It's first gonna go to 23.14. Now which is 23.14? That's your ABR router. Okay, so if you do a trace route, it's first gonna send to this router. This router is then gonna send to ASBR, and ASBR is gonna take it to the Tokyo data center. Okay, so that's a path that's followed here as of now. And you, if you notice this routes will be consistent all on all the routers. Okay, so show IP route. So you will see very consistency in case of OSPF. That's why it's called as link state. They're gonna maintain every track records of all the links. Okay, and what about the other routers of other areas? So in the case of Mumbai 5 router, show IP route. So you're gonna see these routes. Okay, very unique database will be maintained in the case of OSPF about all the links. Fine. Now regarding the LSAs, okay, come back to router 1. Okay, I'm considering this router. Let's see the LSA flow now. So show IP OSPF database. So you will be seeing a lot of new things now. So what do we have here first? So I have my LSA1, which is a router LSA. I have LSA2, which is called as network LSA, and this LSA are seen only when there is a DR election. If there is no DR election, then this will be not seen. The next one is LSA3, which is generated by area border router. Area border router in the sense, two different OSPF areas, the router which is connecting between two different OSPF areas, that is ASBR. And then you see LSA4, and LSA5. What is LSA5? What are these networks? These are the EIGRP networks, which is also called as external routing protocol in this scenario. This can be anything. Don't take it as always EIGRP. It could be BGP, it could be RIP, it could be any other thing, a static also. But in my example, I'm considering EIGRP. Now this is called as external routes. Okay, EIGRP. Now from the point of OSPF to reach EIGRP, who is acting as a gateway? Now gateway is nothing but so let's say this is type 4. Okay, that's LSA4. Now who is acting as a gateway? This is gateway. Okay, which is ASBR. This is ABR. Okay, how is they connected? So let me tell you. So in my scenario, this is area 0. Area 0 was connecting to 40 and area 40 was connecting to EIGRP. Okay, so the router on area 0 will not know how do we reach EIGRP. So in this scenario, I need to have LSA4 to reach EIGRP. Now what about the areas that is directly connected with external route? Do you think the LSA4 would be seen inside area 40? Let's check that. Okay, so let me go to one of the router. It should be either 5 or 6. Okay, 5 or 6. In the case of 5 or 6, if I make use of the same OSPF database command, so you will see there is no LSA4 now. Okay, so let me clear this. So what is this? This is LSA1. What is this? This is LSA2. What is this? This is LSA3. What is this? This is LSA5. Now where is LSA4? There is no LSA4 here because this area is directly connected to the external routing protocol. This area, the area 40, has the ASBR in it. So it doesn't need to know the gateway. But when we talk about another area, it needs to know the gateway to reach towards external routing protocol. That is where your LSA4 get generated in the case of the non attached ASBR areas. I don't say it area 0 always. It could be any area. Let's say there were one more area called as area 20. Now this area 20 will see a LSA4 because of the fact they are not directly connected with this. So just take it in this way. The external routing protocol, whenever they are connecting adjacent with any OSPF, they don't need any LSA4 because the ASBR router will be shared. But apart from that, it could be area 0, 4, 30, whatever area apart from the adjacent, okay, they will have the LSA4. So LSA4 is acting as a gateway to take this OSPF routes towards EIGRP routes. Okay, so we covered lot of ASA. Now let me show you one more thing. That is, let's say I have these external routes over here. I can see 113, I can see 114, and this is same thing maintained over here as well, 113, 114. Now the same thing will be also maintained on this poor router. Now let's say this router is on very small data center, okay, very small data center, and the router is running on 800 platform. Now this router is just doing its basic requirement. It doesn't need to know the individual routes like what is 113, what is 114. It doesn't need to know, but at the same time, it for some reason it still wants to have the reachability. Okay, so how would be the reachability? Let's say it will go to area 0, area 0 will push to area 40, and then it will go to the EIGRP, right? So it needs to know the reachability, but at the same time it want to suppress all these individual routes. They don't need in their routing table. Okay, so let's first see if those routes are introduced in the routing table or not. So this is the roam router 1. If I make use of show IP route, okay, so there is nothing as of now because might be there is no OSPF configured. Yeah, so I'll configure OSPF first. Router OSPF process ID 1. What is the network that I want to define? So let's say I want to define this network. What is the subnet wildcard mask? What is the area? So let's say this is area. What is the area that I mentioned here? Okay, I think I should have it in my configurations. Okay, area 80. So take this as area 80. Okay, I'll just bring it over here. So this is gonna be labeled as 80. So don't worry, you will get the new diagram once we complete this. Okay, so there we go. We have area 80 configured for roam data center. So this is 80. Okay, now who is it pairing with? It's going to pair with this. So I need to have OSPF configured there. Okay, so basically multi-area OSPF. So that's router 2. Let me see the OSPF configuration here. So there is no area 80. I don't have anything for area 80. So that's what I am going to do now. So I'll go to router OSPF 100. I'll say network 33.33.0 subnet mask area 80. Okay, so they will build a OSPF neighborship. The database will be synchronized, and by default, whatever the theoretical concept, all the external routes will be shown up in this case. Okay, in the roam router. So let's see how much time is it going to take. Okay, so it was very instant. So inside roam router, in this poor router, a small side router, it has the external routes 113 and 114. Now I don't need them. Okay, I don't need them. So what can I do is I'll go to once again my routers process. Okay, so let's say router OSPF 1. Okay, so I think I can go towards interface E01. I say IP OSPF. Okay, so OSPF what process ID 1 area 80. Okay, so looks like that's inside OSPF process. Okay, so over here area 80 stub, one single command. Now as soon as I do that, my neighborship is going to go down. That's again we have gone through. Okay, so why did it go down? Because of my network type. So this is the network type. Okay, on other side I have non stub. See, on this side I have no stub, but on this side I configured stub. So as we learned from our neighborship, the OSPF neighborship, one of the factor is the area type. Okay, sorry, not network type, area type. So if there is a mismatch between area type, then the neighborship is gonna break. So what I going to do is I am going to configure stub over here so that they form a neighborship. Okay. So what is the router? It's Mumbai 2. Configuration T, router OSPF 100, area 80 is gonna be stub. Okay. So as soon as I do this, my process will come up. Okay, process has come up, but how is my routing table gonna be compressed? If you see, earlier I had bunch of external routes. Okay, so now let's see what happens. So if you see now, there are no such routes. There is no OE1 or OE2 routes, but additionally there was a default gateway introduced. Okay, so a default gateway which is pointing to 33.33 is making sure you're still reachable. You can give a try. You can ping this route. So let's say you are pinging this EIGRP route. You can still reach. Okay, if you do a trace route, so it went towards 33 first. 33, what is, where is 33? Okay, this is 33. Okay, so from trace route, it first went towards this. From there it went on this, went to towards this. It was taken to this router, and this router took it to the EIGRP route. Okay, so multiple trace route hops that we see in this scenario. So you have 33, you have the ABR, and then you have this 10.10 network, and then finally you are reaching towards EIGRP. Okay, so you have the reachability, but at the same time you have also taken out those external route. Okay, by introducing one single default gateway. Now this is called as stub area. So let me go back to my theory. So what happens in stub area? So let me show you the database. Okay, so when I do show IP OSPF database, so you will be surprised there is no type 5 database, right? See, this is type 1 LSA, type 2 and type 3. There is no LSA 4 and LSA 5. That is a default behavior of stub. If you see this diagram, so in the case of in the case of stub, what's going to happen? There will be no type 5 and there is no type 4 LSA in case of stub. Scenario stub, there will be no such, but at the same time they are going to have the reachability because of the default gateway, uh, addition of the default gateway. Now let me remove this. Okay, let me remove this. The normal, it will revert back to the normal scenario. Okay, so I've removed the stub from both the side. So let's see if I have neighborship. Neighbors are up. How about my routing? So the default gateway has been taken down and you can see the external routes are coming up. Okay, the main purpose of stub is to minimize your routing entries. You don't need 100 of entries inside your routing table. Okay, and parallelly you are also suppressing LSA4 and LSA5. Now if you see the LSA at this moment, so you will see the LSA4 and LSA5 has come up. The more LSA you have on the smaller devices, it's increasing the overhead after all on these routers, right? So basically you're suppressing them by creating stub. Now let's say we are good with a stub scenario. Now let's say there was one more area somewhere here, area 200. Okay, now, since you have enabled stub, you have suppressed all the routing. There is no external routes as of now. You just have pointing default gateway. Now, how is these users gonna connect to the EIGRP? Now, that's going to uh, hurt you, right? That's going to impact your network. There is no way that this can reach out to EIGRP. So, instead of stub, what I would do is I would do nssa, which is called as not so stubby area. Okay, not so stub area. So by doing this, I am still saying no to LSA5, but I am going to generate another LSA called as LSA7. So let's give it a try, and there will be a default route also. So let's say in the case of stub, so we saw there was 1, 2, 3, but there was no 4 and 5. 4 and 5 was replaced by a summary route pointing in this direction. Okay, this was the configuration for that. So in the case of non so stubby area, I'm going to tell you something. Yes, there is one more which I'll discuss. Okay, but before that, let me tell you what is not so stubby area. So in the case of non so stubby area, you will see the LSA 1, 2, 3, 7, but there will be no LSA 5. That there will be no LSA 5, but there will be a new additional LSA called as 7, which is non so stubby area. Okay, that is to maintain external routing beyond this area. So you got the scenario, I guess, right? Okay, let me go to the OSPF process. Let's say area 80 is non so stubby. I'm going to the first not first router. I go to the second router. In this case, this is a second router, Mumbai router. Okay, so I go to Mumbai router 2. I say area 80 is not so stubby. Okay, so the process will come up. Let's give a double check by show IP OSPF neighbor. So we can see they are forming neighbor. Now how about our routing table? So routing table being taken care, there is no 113, there is no 114. Okay, do we have the reachability? First let's confirm that. So can I still reach do ping this IP? Okay, so if you see here, there is no ping reachability. So give me a second. Okay, so you have 113, you have 114. Do show run section OSPF. Okay, so you made your area 80 as non so stubby. Okay, what about our OSPF link state advertisement? Okay, so looks like this has not triggered up. So basically this should have triggered up the new LSA called as LSA 7. So why do we need non-so stubby area? The motivation behind non-so stubby area is to allow the stub areas to carry external routes. Okay, so basically stub would change the behavior. Stub would have blocked it, but with the help of NSSA, I'm going to make this stub carry the external routes. Routes learned using other routing protocols. Stub area are defined as area that are not capable of carrying. Okay. So looks like I need to have one more area, then I can show the behavior of NSSA. Okay. So I'll configure this as stub, and then I'll configure this as non-so stub area. So might be I'll do this in the next lab. Okay. So NSSA I'll show in the next lab. I'll show the remaining things now. That is totally stub area. Now what is totally stub area? Okay. So in the case of stub area, you saw LSA 1, 2, 3 and a default route. Now let's say you want to suppress this LSA also. So you can introduce total stub area. So only the thing is you just need to add one additional line called as no summary. The moment you add this, 3 is gonna get suppressed. Okay. So now you can see only LSA 1 and 2 and there is no 3 LSA. So something like this. It's going to allow 1, 2, 7 and the summary. Okay. But there will be no 5 and 3. So if you want, I can show you. Let's go to this. Let's go to, okay, I'm already on that. Okay, I don't need this. I'll configure this to be stub first. Okay, I'll go to the second router. So I'll say no to this. I'll configure this stub. Okay, so this will bring up my OSPF. Great, and I should have a reachability to my external routing. Okay, so there it go. And what about my LSA? Show IP OSPF database. So I see 1, type 2 and type 3. Okay, so as soon as I enable totally stub, this will be taken out. Okay, so these LSA will be taken out, LSA 3 will be taken out. What is my routing table? Routing table has a default gateway injected. Fine, let's configure totally stub. So just a single command which is called as no summary. Okay, and on the other side I'm going to do the same thing, no summary. Okay, so let's check it out. Database. Okay, so if you see now, the LSA 3 is been minimized. Okay, so they have injected a default route. So let's see from show IP route concern. So from IP route, so you can see there is the default gateway. Can I still reach to the EIGRP? Yes, I can still reach towards EIGRP. My routing has been reduced. Okay, and from my LSA point of view, I only have one default gateway replaced. If you just see, previously you had multiple links. Now those links have been replaced by a default gateway. So this happens when you bring in the totally stub area. So you are going to take out type 5, which is a behavior of stub, but as well as you are going to take out the type 3 LSA. Not completely, but yes, you are going to minimize the flow. Okay. Non so stubby area, I'll also show in the next class. I'll show you what happens in non so stubby area. So there are two things over there. One is called N bit and E bit and P bit, okay, which I'll discuss while taking the lab. This is the summarized version. In the normal area, area 0, all the LSA will be running 1, 2, 3, 4, 5, 7, everything. In the case of stub, you are going to suppress type 5 LSA. In the case of totally stub, you are going to suppress even 3 uh, along with 4 and 5. Okay, so in stub it is 4 and 5. In case of stub, you are also suppressing 3. In the case of non so stubby area, you are suppressing you are not yes, you are suppressing 5, but you are generating one more LSA called as 7. Okay, and in the case of non so stubby area, you are suppressing even the 3, 4 and 5 and bringing in the 7th one. Okay, so yes, we are running out of time. In the next class, I will discuss about the path selection, about the intra area, inter area. So might be I'll show you once what are these things. So if you just open up the routing table, so you will see few tags here. So here IA is nothing but inter area. Inter area is nothing but between two areas. Okay. For intra area, you don't need any any indications or any labels. So basically, O is nothing but intra itself. Intra is when okay. So intra is when it's within the same area. Okay. So in my case, this is same area. So the routes will be tagged as O. When I have two different areas, it's called as inter area, and which will be tagged with this notation IA. Okay, IA is nothing but inter area. Similar way, you will also see E2 and E1. E2 and E1. OSPF external type 1 and type 2. Now this is again interview question. Which one is preferred? Type 1 is preferred or type 2 is preferred? So anyone knows which one is best, which one is getting preferred. So as of now, you can see E2 is picked up. But if I talk about E1 and E2, let's say E1 versus E2, which one is better among this? So anyone wants to may I know the reason? So on what factor? Okay, not an issue, not an issue, not an issue. I was just asking, might be if you know. Okay, okay. Well, so answer is not E2, it's E1. The reason is the way they calculate the cost. In the case of E2, they are gonna be a single cost. Okay, so they are going to ignore lot of path and they are just going to consider what do you say, they are just going to come they are just going to see the overview, I can say overview. But in the case of E1, they are gonna calculate individual path. Now let's say in my scenario, in this scenario, it has taken up E2 by default. That's a default behavior. It will take E2. In the case of E2, the cost from, or let's say cost over here, should have been this, this, and this. Okay, if you ignore this switch, so this would be one cost, this would be the second cost, and then from this router to this router it would be the third cost. Okay, but so that is in the case of E1. How is E1 gonna work? It's gonna calculate the cost of every path. But in the case of E2, it's just going to take a overview. That's, let's say now it's just be 10. Okay, now what happens is, let's say there were two ways to reach the destination. Now there occurs issues. Okay, in the case of E2, it's just a overview. Now this could have been a serial link as well. Okay, and if the serial link takes up just 5, and the better interface is taking up 10 in case of overview. Now E2 is going to prefer this. Okay, but in the case of E1, it's going to take individual consideration. It's going to see that it is taking 10 plus 10 plus 10, 30, and in the case of serial, it's taking up 40. Okay, it's going to take 40. Now which is better? Even though you have two hops, the cost is just 30, but in the case of serial link, even though there is only one single hop, but the cost is 40. So basically 30 is lower than 40, right? So that is why. So E1 is the real cost factor. It's going to consider the cost of the real interfaces, whereas E2 is just taking up the overview or just taking up the counts. So let me show you as of now. If you see the cost of E2, see what is the cost? It's just 10. Do you think that 10 is the right cost in the case of this? So from here till here is just showing as 10. That's a wrong cost. Okay, how could it be 10? So basically this would be 10, you have another 10, and you have another 10. So basically that should have been 30. So in case of E2, it's going to show you the cost of or the overview cost, whereas in the case of E1, it's going to show you the individual cost. So from the point of E1 versus E2, E1 is better because they are showing the real cost. Okay, so this is a scenario when, as I told you, if there is serial link, just a single link which has a cost of 64, whereas the other link, even they are 4 hops or 5 hops, in case of fast Ethernet or in the case of Giga Ethernet, the cost is just 1. So even if you have 10 hops, they are going to be just 10 cost. One serial link going to be 64. By default, E2 will take up this link, but E1 is going to take this link. So it's about how it works. Okay, so anything which you are seeing for the first time apart from what we have not discussed, the things which we discussed today. So what have we discussed today? Let me just give an overview. So we started up with network types, LSA, types of LSA, 1, 2, 3, 4, 5, 7, and then area types. Okay, so we know what is stub area, how they behave, what is going to happen with respective to LSA and the routing table. We also know what is going to happen in the case of totally stub area. Regards to this, I will take up in the next class. Okay, I have to bring up one more area here, somewhere over here, and I will show you the configurations. Okay, and what is left then? So I am left with the path selection, the metric calculations, and then I have summarization, route filtering, and some small portions. Okay, so probably I can complete this in the next class. Okay, now one last thing before I wind up, I want to show you the Wireshark capture. So in the case of stub, you will see that external routing capacities would have been suppressed. Okay. Okay. Now it's shown up. In the previous class, when I was trying to show you, it wasn't working. So now you can see the external routing has been suppressed. So 0 is suppressed. So that means there is no LSA 5. Also LSA 4. There is no LSA 4 and 5. This is basically to suppress the external routing. How does it suppress the external routing? It's just going to inject one default gateway, and it's going to remove those 113 and 114 that we just checked in the class today. Okay. Same thing. Let's say let's see in one of the other router. Okay, a normal router which is behaving normally. So let's say from this. So do we have the external routing enabled on the Wireshark? So you will see the external routings are capable, whereas on the stub area the external routings are disabled. Okay, so if you see external routings are enabled, that means there is LSA 5. In the routing tables you will see all the individual entries. There will be LSA 4. Okay, so these are the behavior of the normal areas where you have external routing, and when you are disabling or when you are suppressing, then you will see this behavior. And one more fact is, you cannot suppress your area 0 networks. So let's go to one of the router of area 1. So it's on process 100. Okay, this is the reason, make use of a unique or the consistent process ID. Okay, just keep it one. This was to demonstrate that 101 or the process ID, different process ID can still work, but it will lead to confusion later on when you're going with configurations. You might end up configuring on OSPF process 1. Okay, so that will not be effective. You should make use of the process ID the one which you are advertising. So that is why I go and check this command every time to make sure it's on 100 or 1 or whatever. Okay, so what I'm going to do here is I'm going to okay, so I'm going to suppress stub. That was my task, right? So when I try to do that, when I have already made use of area 80 stub, it has taken up the config. But when I try to suppress area 0, it says that backbone cannot be configured as stub area. So why is it happening? So the reason is, as you know, area 0 is the backbone. Okay, so you have n number of areas. So all the other areas are all connected to area zeros. So if you suppress external routing, that means you're suppressing the external routes from all the other areas. So you cannot suppress external routing on area 0. Yes, you can suppress over here. You can do it over here with the help of the stub commands, but not on area 0. Okay, fine. So let me see the chat window, and we will wind up. Okay, so I would prefer it doing after the class, because till beginning of the class I was preparing the notes and workbook, so I don't think I can upload it before the class. Okay. Okay, so I was asking if it's going to take E1 or E2. Which one is it going to take? So I'm not sure what do you mean by this. Can you summarize anything in A0? Yeah, but what do you mean by can you summarize anything in area 0? So we discussed about the default route in no, in the stub areas. Okay. Okay. So this point. Okay. So we discussed about the default route in one of the other areas where I make use of stub, not in the area 0. Okay. In area 0, there is a concept called as default originate. Okay, which is going to add something called 0.0 dot, but that is on different context. Okay, which I'll tell you. That is not with respect to suppressing of any LSA or something. Okay, this is when, let's say, okay, let me just give you one scenario. So if you see from the lab what we had today, how did I inject two different routing protocol with the help of redistribution? Okay, now this needs little bit knowledge on redistribution, like what is the metric or how is it going to inject. But there is another way to do that, that's called as default originate. Okay, so with the help of default originate, I can put a external routing facing to the facing all the default network facing to one of the gateway. Okay, so that is a different context. I am not sure what do you mean by this. That is not called default route, it's called as summarization. So the thing what you're talking about is summarization. So with the help of summarization, I can reduce this 50 route into single route. Let's say I have 192.168.1.0/24 in my routing table. Similar way, I have 192.168.2.0/24. I have 192.168.3.0/24 and bunch of other line. Now, with the help of summarization, I can make it 192.168.0.0/16. Now, all this will be summarized and just be placed as single route. So that is a solution for your question. Okay. Default route is a different concept. The one example we discussed in the case of stub, during default originate scenario, I will show you how is it going to make use of the default uh, default route, which is an alternative for redistribution. Okay, so default originate is a inbuilt command in OSPF. You don't need to have redistribution. Okay, so any other doubt before we wind up? Okay, so guys, have let's meet in the next class and have a nice day till then. See you all. Take care.